The drill is a machine tool used to make holes in metallic and non-metallic materials using a rotating tool called a drill bit. Its main purpose is to drill holes, but it can also be used for other operations such as enlarging holes, countersinking, and internal threading, known as tapping. The drill works through a rotating motion of the tool and a forward motion that pushes the tool against the workpiece, removing material in the form of chips. The rotation speed and the feed rate must be adjusted according to the material of the workpiece and the diameter of the hole to be made. There are different types of drills, each designed for specific tasks. Drills can be classified based on different criteria, including the position of the working axis, their use, the number of spindles, and the arrangement of the spindles. Regarding the position of the working axis, the most common types are the vertical drill, the horizontal drill, and the radial drill. In the vertical drill, the rotation axis of the drill bit is vertical, and the workpiece is placed on a fixed table. This type of drill is ideal for making holes perpendicular to the surface of the workpiece. On the other hand, in the horizontal drill, the rotation axis is horizontal. It is used for holes parallel to the surface or for special operations. The radial drill has an adjustable arm that allows the tool to move over a large working area without moving the workpiece. This type of drill is useful for working on large pieces. Based on their use, drills can be divided into portable and fixed drills. Portable drills are smaller and easier to handle, suitable for small jobs or hard-to-reach areas. They can be electric or battery-powered. Fixed drills, on the other hand, are mounted on a base or a workbench. They provide greater stability and precision, making them suitable for repetitive tasks or high-precision operations. According to the number of spindles, drills can have one or more spindles. Single spindle drills make one hole at a time, while multi-spindle drills can make several holes simultaneously, increasing productivity. In terms of spindle arrangement, drills can be aligned or not. When the spindles are arranged in a straight line, they allow drilling multiple aligned points on a workpiece. To ensure accuracy and repeatability in drilling, a device called a drilling jig is used. This is a guiding tool that ensures the correct positioning of the drill bit on the workpiece, preventing alignment errors and ensuring consistency in repetitive operations. The drilling jig is made of a metal or hard plastic plate with guide bushings that direct the drill bit during the drilling process. The jig is securely fixed to the workpiece to prevent movement during the operation. There are simple jigs used for single holes and complex jigs designed for a series of holes with predefined positions. Drilling is a mechanical operation used to create holes in metallic or non-metallic materials using a rotating tool called a drill bit. This process involves chip removal, where the material is gradually removed as the tool rotates and moves forward into the workpiece. Drilling works through two main movements, the cutting motion and the feed motion. In the cutting motion, the drill bit rotates at high speed, removing material in the form of chips. In the feed motion, the drill bit is pushed against the workpiece, gradually penetrating the material. To obtain accurate and clean holes, it is necessary to adjust the cutting speed and the feed rate according to the type of material and the diameter of the hole. In some cases, a lubricant is used to cool the tool and improve the surface finish of the hole. The drilling process is divided into several phases. First, the marking phase takes place, in which the exact point where the hole is to be made is marked on the workpiece using a punch to prevent the drill bit from slipping. Next, the workpiece is mounted on the machine by securely fixing it to the drill's table or bench, ensuring stability and accuracy. After mounting the workpiece, the cutting speed and feed rate are set according to the material and the diameter of the hole. If needed, a drilling jig is prepared to ensure accuracy and repeatability, especially in repetitive tasks. The actual drilling then begins, with the tool advancing into the workpiece at a constant and controlled pressure. If necessary, a lubricant is applied to cool the tool and improve the quality of the hole. The most commonly used tool for drilling is the twist drill bit, known for its specific design that ensures accuracy and efficiency. Twist drill bits are made up of three main parts: the cutting body, the cutting edges, and the shank. The cutting body is the main part of the drill bit, featuring two helical flutes that help remove the chips and allow the bit to penetrate the material. The cutting edges are the sharp edges at the end of the drill bit that perform the cutting action during rotation. Finally, the shank is the end part of the drill bit that is clamped into the drill's chuck. The shank can be cylindrical or tapered to ensure a secure grip. Twist drill bits work effectively thanks to the point angle, usually 118 degrees or 135 degrees depending on the material, and the cutting edge inclination, which determine the rake angle for efficient chip removal. A larger point angle is used for harder materials, while a smaller point angle is ideal for softer materials. There are different types of twist drill bits, each designed for specific materials and applications. The most common types are Type M, Type D, and Type T. Type M drill bits have a standard geometry suitable for medium-hard metallic materials such as mild steel, aluminum, and brass. Type D drill bits are designed for deep holes, with wider flutes to facilitate chip removal. They are mainly used on hard materials such as alloy steels and stainless steels. Type T drill bits have a larger point angle and a more robust structure, making them suitable for tough and hard materials such as cast iron, hardened steels, and nickel alloys.